So now let's see if we can train a classifier on rocks versus mines. So to do this, we're going to use a package in Python called sklearn or skykit-learn, sci-kit.learn or something like that. Anyway, we've got this here. So we get sklearn, we import data sets, and we import the linear model. We're going to use a linear model here. And we will import this. I'll do it again anyway, but these are the metrics we're going to focus on, the ROC curve and the AUC. And I'll explain that as we go along. And we can work with this here. So let me import it before I forget. And we'll also import NumPy and random because they're useful for building our training and testing samples. Then we read the data, of course. So we've got that. We've already done that before. And now the first thing we want to do is we want to take our dependent variable, which are currently 2 characters, R and M, and convert them into 0 and 1. Because when you're doing a regression, our dependent variable has to be numerical. So we convert that into 0, 1, and we're going to use our np.where. If you recall this one, this is like the Excel if. And what it says is wherever df60, which is the dependent variable column, equals R, you pop a 0, and otherwise you put a 1. And we know that from our earlier examination that the unique values are only R and M. So we won't have any NAs or anything else to deal with. So we take our df60 and we convert it from R and M into 0 and 1. The next thing we need to do is to divide the data set into training and test samples. Now obviously we can take our entire data set and run it and get the result and then hope for the best when something new comes in. But that's not going to be really a great idea, because what we want to do is we want to see whether the results that we get are robust or not. If they're not robust, then we don't want to use them when we send our troops or people into the minefield. To test whether it's robust or not, typically what you do is you take your data set and divide it into 2 parts, a training and a testing sample. You train the machine on the training sample and then test it on the testing sample to see whether the results you got from the training sample actually make sense with some data that you haven't used in training in trying to parameterize or train your model. So that's a really important step. If you don't do that, you get into trouble. You have to understand, you have to make sure that your results are going to be reasonably robust. Otherwise, you're going to be in trouble. So training and testing, and in fact, often people use a holdout sample, completely unseen sample that they then, after they've trained the model on training and testing, and they've tested it out and looked at different ways of training it, then they finally take a third sample that hasn't been used at all in the process and see whether the results hold over there. For example, you might train your model using one classification technique and then try another classification technique and try a third classification technique, and then you pick the one that looks the best. But at this point, you've only trained on one set of data, tested another set of data, and then you use that to pick a model. So now you want to see whether that process of training and testing has sort of biased your results to whatever data was in the training and testing samples. So now you'd pick a third one and test it out there, and hopefully it'll work out well. We'll use only a training and testing sample. And sklearn has a model selection package which contains a function called train test split. What that does is you give it the fraction of data that you want in your test sample. I think test size equals 0.3 over here. You give it a data frame, and it's going to split the thing into 2 data frames, a training and testing one, and then we've got that. So once we have a training and testing, we're going to pull out from our data frame the independent variables. That's column 0, row 0 onwards to 0:60, which is from the training. So we have 2 things here, training and testing. Let me run this, and we can see this for a second. Okay, insert cell above. So here, if I look at train, we see it's a data frame, and it has row 6, row 193, row 179, row 139, row 94, row 24 in it. So it's randomly picked a certain set of rows from our data frame, and that goes in the training, and the other rows have gone into testing, the ones that are not in this thing here. So that's our our train, and from the training, from this data frame, that is our training data frame, the one that we just saw here, we pick the columns 0 through 60, that is 0 through 59. Remember, the last one doesn't get included. So these are our independent variable columns, and they go into the X train, which is our training data set, the independent variables in our training data set, and the 60th column, that is actually 61st, but that goes into Y train, which is our dependent variable. And similarly, we do the same for X test and Y test for the testing sample. And notice we use the iLock here because we are using row indices to pick data. And when you use row indices, you use iLock. If you use the row numbers 0, 1, 2, 3, 4, then you use iLock. If you use the actual index, we don't have an index here, but if you add an index and use the actual index, you could use .loc instead. So this gives us our thing here, and we see that Y training contains 6 193.179, which pretty much corresponds to the 6 193.179, 139, 94. So they are aligned. We want aligned data in our training and testing samples. So once we have that, then we build our model and fit the training data. And this is the standard procedure, regardless of which particular model you're using for machine learning from the sklearn package. You're going to use the same 2 steps. You're going to first start by building a model itself. So you get this, and we're going to use linear regression over here. I should point out that for our data, logistic regression is another option, which is probably slightly better. But because I want to explain how to the various methods for evaluating results, we'll use linear regression here. To use logistic regression, you just replace linear regression by logistic regression, and then most of what we're going to do is probably going to work equally well with that. And but anyway, so we have here, we're going to use from the linear models in sklearn. We're going to be picking the linear regression package, and we create this model here. And then what we want to do is we want to fit the model to our training data. And to fit the model, you tell it what your training sample independent variable values are and what the corresponding dependent variables are, and that will fit the model for us. So this is pretty much what we will do regardless of which particular model we happen to be using. So once we've done that, we've fitted our model, and now we can start thinking about how to interpret the results.